For example, if you're taking a spring and you're applying a force onto that particular string, then obviously you know that when you let go or you increase the force, automatically the spring will rebound. If I take the ratio of that particular change in length to the actual length, then that particular ratio is known as strain. So this is compressive force being applied, so automatically instead of tensile stress, it will be compressive stress. And when we pull it apart, it is tensile stress. Hey all, I'm Hari Krishnan from the Department of Physics, Vidhyaashram PU College, the Temple of Excellence, and we are going to start a new chapter today, that is mechanical properties of solids. So we already know what solid materials are. That is, when we apply some stress, it does not change its shape. So that particular property or that particular property possessing materials are known as solids. So this kind of solids has certain kind of mechanics, and we are going to study all about that kind of mechanics in this particular session. So let's start. So the first thing we are going to see here is elasticity. So what exactly is elasticity? You might have seen elastics, or you have seen elastomers in your life. But what exactly is elasticity? Like, we have a general understanding. So elasticity just means that if we apply a deforming force to any object, if it is able to regain its initial shape and size, then we say that that particular material has a certain amount of elasticity. For example, if you pull or push apart any material to the sides, to the left, to the right, radially, like different ways, if the material is able to regain its original shape and size within a short period of time, then we say that then that particular material has elasticity or elastic properties. So we can just define elasticity as the property of the material, or by virtue of which, if we stop or remove the deforming force, deformation just means that it is changing its shape or condition. So we say that when we stop applying the deformation force, if we remove the deformation force, if the object is able to regain, its original size and shape, then we say that that particular quality is known as elasticity. So again, remember, the force which we are applying is known as deformation force, and the property of any material to regain its shape and size, initial shape and size, when we stop applying the deformation force, or simply if we remove the deforming force, if it is able to regain its original shape and size, we say that that material possesses the quality that is known as elasticity. That is 1. 2 is, what is stress? It is not the stress which you get during your exams or certain tests, or when you can't answer anything. This particular stress stress actually entails to the stress which we apply to solids. So again, what is stress? Is it a form of force? Is it something else? Is it a form of force combined with something else? So let's see. So if we want to define stress in terms of words, we can actually say that when a body is subjected to deforming force, that is, when we apply a certain amount of force to deform that particular object, then automatically a restoring force is developed in that particular body. For example, if you're taking a spring and you're applying a force onto that particular string, then obviously you know that when you let go or you decrease the force, automatically the spring will rebound. That is because the spring inherently has a restoring force developed inside that particular spring. Just like that, any material, any solid, when it is subjected to a deforming force, there is a restoring force developed inside that particular body. So this restoring force is equal to the magnitude of the force which we applied. That is, it is equal to the magnitude of the deforming force which we applied. And it is in the opposite direction. That is just saying that if I apply some force to a spring, then automatically it generates or it stores that particular restoring force. This particular restoring force is in the opposite direction of the applied force, right? that particular restoring force developed per unit area is known as stress. Or simply you can say that the magnitude of stress will be equal to force by area. That is, it resembles the equation for pressure, but again, the magnitude of stress is equal to force by area. Or in simple terms, we can simply say that stress is nothing but restoring force developed per unit area. So in one simple term or one simple sentence, if you want to say what is stress, you can actually say that it is nothing but the restoring force developed per unit area. If I apply a force, there is a restoring force, or there is a force that is existing in the opposite direction. When that particular force is expressed in terms of unit area, that particular term or that particular force is known as stress. So when we apply force to any solid object, it develops stress. That is a restoring force per unit area, that is known as stress. That is 2. Now 3. Now 3 is strain. So what exactly is strain? People might say that don't look at the screen too close. You'll strain your eyes. Don't be near to the smart screen. It will strain your eyes, right? But what exactly is that strain? Again, it can and cannot be related to the strain I am here talking about purely strain in terms of physical aspects or simply mechanical aspects. So here I can actually simply define strain as the ratio of the change in length to the original length, or in one simple term I can say that it is the ratio of change in dimensions to the original dimension. It is one loose way of interpreting this particular result. That is, if I have a string or a spring and if I stretch it or compress it, then the length of that particular material changes, right? If I have a spring, if I compress or stretch it, the length changes. So here the dimension is length. So if I take the ratio of that particular change in length to the actual length, then that particular ratio is known as strain. For example, if the change in length is delta L and the original length is L, then this particular ratio is known as strain. And the last thing is that this does not have an SI unit, because change in length just means that it is length, and the original length also means it is length. So if I try to take the SI unit, it is meter by meter, it cancels out and it has no dimensions and no SI units. So again, but strain is a unitless quantity, but it is an actual quantity and you actually need strain. So we have learned about 3 things. One is strain, one is stress, and the last one is elasticity. And now we are going to learn different types of stresses and strains that is subjected to different types of solids. So mainly there are 3 different ways a solid can change its dimension when we apply external force to it. So we are going to divide this into 3 categories of strains and stresses, and then we are going to analyze what is the differences, what is the key points, and how it is happening. Okay, so let's start with the first 3 forms of stresses that is being applied. So the 3 ways a solid can change its form or dimensions when we apply a force is mainly through tensile stress, shearing stress, and hydraulic stress. So what exactly is this tensile stress? What is this shearing stress? And what is this hydraulic stress? That is what we are going to discuss very soon. But again, you have to know that. So these are the 3 important ways we can actually subject a force or simply apply a stress in order to change the dimensions of any solid materials. So you might have heard this term actually a lot, that is tensile strength. This is actually used in steel industries, and Mostly if you have any steel threads or any ropes, you actually measure it in terms of tensile strength, how much stress it can bear. So simply we can say that tensile stress is much more of a common word to us rather to or comparing to shearing stress and hydraulic stress. But you have also heard about hydraulic pressure, like in terms of cranes or in terms of hydraulic presses. You might have heard about hydraulic stresses also. But shearing stress, I don't think any of you have heard so much about. But don't worry, we are going to learn about what all these three kinds of stresses actually are. And corresponding to these three stresses, there are three strains also. So corresponding to tensile stress, there is not tensile strain, but rather longitudinal strain. Longitudinal strain. And corresponding to shearing stress, we have shearing strain. And corresponding to hydraulic stress, we have, so we are not going to say because you messed up the first two. Yeah, corresponding to hydraulic stress, we have volume strain. So again, if you look at the left-hand side, my left-hand side, then you can actually see that longitudinal strain just means it is something related to the length. Shearing strain is somewhat different, so I'll let you know what shearing strain is. And finally, the volume strain is actually the change in volume. So here we are actually measuring the changes in dimensions on the left-hand side through strain, and here on the right-hand side, I am measuring what is the nature of the force that is being applied, what is happening to that particular material of solid, like is it deforming? When I apply that particular deforming force, how much strain and stress is caused to that particular material, what is the properties of that particular material, and how we can select different types of materials for different uses, all can be understood through these three types of properties. So again, the first one is nothing but the tensile stress and the longitudinal strain. So what is tensile stress? So tensile stress just means that if we have any cylindrical objects, for example, let's take a rope or a wire, and if I apply force onto the both sides, both ends, if I pull from this side and to that side at the same time with equal amount of forces but in opposite directions, then that particular deforming force that is applied equal in magnitude but opposite in direction, normal to this particular cylindrical surface, then I can say that that particular stress applied is known as tensile stress. So simply you have a cylindrical medium which is having a length of L, and then we are applying a force equal in magnitude but opposite in direction, then I can literally say that, okay, that particular stress I'm applying is known as tensile stress. And what is longitudinal strain? Longitudinal strain is nothing but, again, strain is the ratio, it is the ratio of change in dimension to the original dimension. Here the changing dimension is length. So initially if it had a length of L, through my pulling or pushing, you have a new length that is delta L that is being added to the original length, because we are stretching it out, right? So then I can simply say that the change in dimension, that is delta L divided by the original dimension, that is L, will give you longitudinal strain. So again, tensile stress is nothing but the restoring force that is developed per unit area when we apply an external force. That is, if you are giving the force like this, it is known as compressive force. But again, you don't have to study about compressive forces, but just so you know, so this is compressive force being applied. So automatically, instead of tensile stress, it will be compressive stress. And when we pull it apart, it is tensile stress. So that is usually measured because we hang certain objects using steel cables or like ropes and all that. In order to study that particular tensile strength, we have to study about tensile stress. So that is why we are focusing more on tensile stress instead of compressive stress. So what exactly is shearing stress and shearing strain? Again, strain you might have already understood. It is the change in dimension to the original dimension, but what is stress? Again, so if I take the same exact case of a cylinder, then I can actually say that if I apply the force which is parallel to this particular cross-sectional area. So if I take this to be the cross-sectional area, in the previous case I applied the force which is perpendicular to that particular cross-sectional area. Now I am applying that force parallelly to that particular cross-sectional area. So if I apply that force parallelly to that particular cross-sectional area of a cylinder, in that is two forces which is equal and opposite in direction. That is, if I apply a force, the restoring force is the opposite direction. That is why it is a pair of forces. But again, if I apply that particular force parallelly or tangentially to that particular cross-sectional area, there is a relative change. There is a relative change in displacement of these two faces. Let's say that is through an angle of theta. That is, this is not moving and this is slightly bent. For example, imagine the case of a punching bag which is glued to the ground. If I hit it, then what happens? As soon as I apply the force, the punching bag which is glued to the ground is actually tilting. I'm applying the force tangentially and the punching bag is tilted through an angle, let's say, of theta. Which means if I measure the distance between the initial face, that is one face which is glued to the ground and the other face which has now moved on, there will be a small change in displacement, or there will be a change here in terms of length. So I can say that, okay, that particular change is delta x. So if there is a change like that, when a tangential force is applied, then I can say that, okay, that particular force applied or that particular restoring force developed per unit area is known as shearing stress. And what is shearing strain? So shearing strain is nothing but the change in dimension to the original dimension. So again, the original dimension is nothing but the length of this particular cylinder, which we'll take it as L. And the change in dimension is nothing but the relative change in the displacement of these particular faces. So let's say that particular displacement is delta x. Then I can say that, okay, strain or shearing strain, you have to be precise, shearing strain is equal to delta x divided by L. So if I take that particular ratio, you will get the shearing strain. And lastly, we have what is hydraulic stress and volume strain. So again, hydraulic stress means that imagine that you have a beaker of water. You have a beaker of completely filled water. And then you're dropping a pearl into that particular beaker of water. You're dropping that into this water. So in this condition, when the pearl hits the bottom of this particular beaker, it is surrounded by water molecules. So this particular water is nothing but a fluid. So this particular fluid will exert a pressure from all directions to this particular pearl, right? It will exert a force in all particular directions onto that pearl. Now imagine that to be an ocean. In that particular ocean, if any solid object, let's say a pearl again or a ball, if you drop a pearl or a ball or a submarine or whatever it is into the ocean, as it sinks deeper and deeper, the water pressure is too much, which means it is compressing that particular solid object. When we apply a force, a deforming force like this onto that particular solid object, the volume of that particular solid object changes. The volume actually decreases. This particular change or the restoring force developed per unit area in this particular case is known as volume strain or simply hydraulic stress. And volume strain is nothing but the change in volume to the original volume. So again, remember, if you have any solid object, if you immerse it in a fluid, it will have pressure from all sides, and that is the applied deforming force, and because of that there will be a change in volume, and that is known as hydraulic stress. You can also Google up hydraulic presses, and that is also the same thing. They will apply volume strain so that the volume is actually changed. So that is all in this particular class, that is the introduction to mechanical properties of solid. And now in the coming classes, we'll discuss more important laws, elastic limits, Hooke's law, and certain other concepts which are fairly new to you. So I'll see you all in the next class with some new topics. Until then, thank you.